So we're starting a new chapter today, and it's a chapter on what's called translations, okay? And translation is a mapping where you take a pre-image, your original figure, and you map it onto an image, okay? And there's 4 different kinds. We're going to talk about 3 of them in this chapter. The first one is called dilation. We're going to talk about it later this year. But it takes your pre-image, which is your original shape, and it reduces or enlarges it. Kind of like if you take something to the copy machine and zoom in or out, okay? There's a rotation, where it takes your pre-image, your original, and rotates it clockwise or counterclockwise about a certain angle, okay? Our third one is a translation. We're going to talk about it tomorrow. And it takes a pre-image and it slides it left, right, up, down. Sometimes it can get here to go diagonal. And then the last one is a reflection or a flip. Okay, that's where it takes the pre-image and it reflects it through a line of reflection. Okay. All right. So that's what we're going to talk about today: is reflection, a transformation representing the flip of the figure. All right. So this right here is showing ABCDE, which is my pre-image. And it's going to map it onto A prime, B prime, C prime, D prime, E prime, which is my image. So the pre-image is what you start out with, the image is what you end up with. Now, when you reflect it or translate it somehow, the new letters become primes, okay? So your A maps onto A prime, the B maps onto B prime, C onto C prime, okay? They coordinate together. Now, this right here is my line of reflection, okay? That line that I've got drawn there. And you can think of it like if I flipped it and traced A, B, C, D, E back to A, and then I folded it along that line of reflection, it would put that image below, okay? It would be like you kissed it onto the other side, all right? And so that's what we're going to be doing. Now, when that happens, the distance from your point to the line stays the same. So my distance, and it has to be the perpendicular distance from A to the line of reflection, when you reflect it over, that distance stays the same. Okay? And like E to E prime, those 2 distances are the same. Okay? So because if it wasn't the same, then your image would become skewed, it would become distorted. Alright? And so in order to keep it the same exact figure, the distance to the line of reflection has to be both the same when you reflect it over, okay? And what this does is exhibit what's called rigid motion, okay? And rigid motion preserves the length and angle measure of the figure. So it preserves the length and angle measure of the figure. Okay. Alright, so we're going to talk about how to do that. Now, most of the time, it preserves the length and angle measure. Now, the reflections that we're going to do are going to be on the coordinate plane, okay, on the XY coordinate plane. Okay. Alright, so here's the first one. It says that JKL has coordinates, J, K, and L, as you can see. I've already graphed that for you. We are going to label that, which I did, and a reflection over x equals -4. Okay? So when it uses the capital R, that tells me it's reflection. And you're going to reflect over this line right here, x equals -4. And I'm going to take JKL, and I'm going to reflect it onto J prime, K prime, L prime. Alright? So you got to know how to graph x equals -4. Remember I told you in the last chapter, or chapter before, if you take an x and cut it in half, it becomes a V, it's a vertical line. Okay? Also, you can think, okay, go to -4 on the x-axis. 1, 2, 3, 4, and you're going to draw a line through that point. Okay? So, this right here is going to be my line of reflection. And so then what I have to do is fold it along that line. If 1 point is 2 units to the left, like look at L, is 2 units to the left of that line, when I reflect it, it's going to be 2 units to the right. So 1, 2, 1, 2. So the left, it comes on the right. So on the right, it comes to the left. So that's L prime. J prime is 1, 2, 3, 4 to the right. It's going to go 1, 2, 3, 4 to the left. K is 1, 2, 3 to the right. It's going to go 1, 2, 3 to the left. K prime. And then you connect those new points. And you have reflected over that blue line x equals -4. Okay? Now, let's talk about what it would look like if you reflect it over, let's say, reflection over y equals -3. Okay? Triangle JKL. Alright, let's do that. Alright, we're going to use that same triangle. Okay? This time, we're going to reflect over y equals -3. And remember, if you take a y and turn it upside down, it's an h or a horizontal line. Okay? You can also go to -3 on the y-axis, 1, 2, 3, and you draw a line through it. This is y equals -3. Okay? And now I'm going to reflect over that line. So we see that K is 2 units above. When you reflect, it goes 2 units below. You're going to the opposite side, the same distance. Okay, if L is 1, 2, 3, 4 above, I've got to go 1, 2, 3, 4 below. There's L prime. J is 1, 2, 3, 4, 5, 6 above. 1, 2, 3, 4, 5, 6 below. And then you just connect those points. Okay? So you draw the line of reflection, and then you count how far it is on one side. You've got to go the same distance to the other side of the line. Did you have a question, Dalton? Okay. All right. Now, here's some special ones. These have special rules that we're going to discover. Okay? All right. We're going to reflect over the x-axis. Which one's the x-axis? This is the x-axis right here. So we're going to reflect over the x-axis. Okay? All right. So if we reflect over the x-axis, we have to count and see where these points are. So we see that K is 1, 2, 3, 4 below. So when you reflect, you go 1, 2, 3, 4 above. And that's K prime. So that's the coordinates 2, 4. Okay, L is 1, 2, 3 above. So when you reflect, you go 1, 2, 3 below. Okay, and that's -1, -3. M is 2 above. So when you reflect, it becomes 2 below. And that is 1, 2, 3, 4, -2. -4, -2, excuse me. Now, look at these coordinates compared with the pre-image. Do you see a pattern? No? What's opposite? One of them's opposite. Which one? The y, right? In all three cases, the x stayed the same, right? But the y changed signs, yes? Okay? So if that's the case, then what should n prime be? -3, 4. Okay, let's test it. N is 1, 2, 3, 4 below. 1, 2, 3, 4 below, above. Okay, and that is at 1, 2, 3, -3, 1, 2, 3, 4. Perfect. Okay? So, there's a little rule for this. Okay? If you reflect over the x-axis, get your x and y coordinate, your x stays the same and your y changes signs. Okay? So it's the opposite coordinate that changes signs. If you reflect over the x stays the same, the y changes signs. You can do it by graphing like we did here. You can use it with the coordinate, the rule for the coordinates. You really need to understand both. Okay? All right. Let's look at a reflection over the y-axis. Which one's the y-axis? Okay, so this right here is my y-axis. Okay? All right. So if I look at K, K is 2 units to the right. When you reflect, K prime is going to be 2 units to the left. So that puts me at -2, -4. L is 1 unit to the left. If you reflect, it's going to go 1 unit to the right. Okay, that's at 1, 3. N is 1, 2, 3, 4 to the left. So you go 1, 2, 3, 4 to the right. And that puts us at 1, 2, 3, 4, 2. What's happening here? The x changes signs, right? If you're reflecting over the y-axis, the y stays the same and the x changes signs. So a reflection over the y-axis, your x and your y, your x becomes the opposite and your y stays the same. So with that in mind, what would n prime be? 3, -4. Okay, so let's test it. We're 1, 2, 3 to the left, 1, 2, 3 to the right. There's n prime, which is 1, 2, 3, 1, 2, 3, 4. Perfect. Okay, so that rule works. And then you graph it, and you reflect it over the y-axis. So if you reflect over the x-axis, your y changes signs. If you reflect over the y-axis, your x changes signs. So that's the rule. You can graph it, use the rule. Sometimes you've got to do one way, sometimes you need to do it another way. Okay, now we're going to talk about reflecting over the line y equals x and y equals -x. Now, what does that line look like? Okay, well, if you go back to your equation, y equals mx plus b. Okay, the number in front of x is your slope, and the constant is your y-intercept, right? So if I'm looking at y equals x, what's the number in front of the x? A 1. It's understood to be 1, right? So in this case, my slope is 1. There's not a constant. There's not a number that's all by yourself. So your y-intercept is 0. So anytime you reflect over the line y equals x, it is the diagonal line through the origin with a slope of 1. So it goes through the origin, and it goes through the origin, and goes through 0, 0, and you rise 1 and you run 1. Rise 1, run 1. Rise 1, run 1. So forth. And I'm going to draw all these dots because I'm trying to do a good graph. It's hard on this smart work. Okay, so I'm trying to give myself a little direction. Alright, so has a slope of 1. Woo. Alright. Alright, so that's the slope y equals 1. I mean, y equals x. Excuse me. Slope of y equals x. Now, when you reflect here, since this line is diagonal, you have to go add a diagonal to the line, because that distance has to be the same and perpendicular to the line. So, for example, my L, I have to go diagonally across the square instead of horizontal or vertical. So I've got to go diagonal 1, 2, diagonal 1, 2. Okay? And my L prime is going to be right there, which is at 1, 2, 3, -1. Okay, if I look at M, again, I got to go diagonal across the square. 1, 2, 3 diagonal, 1, 2, 3 diagonal. That puts me where K is. And that is at 2, 1, 2, 3, 4. let's look at K. I'm putting you on N, isn't it? Diagonal 1, 2, 3, diagonal 1, 2, 3. So that's going to be my K prime, which is at negative 4, 2. Do you see a pattern that's happening here? They're switching places, aren't they? The X and the Y are switching places. Okay? They're just flip-flopping like that. So the rule for reflection over Y equals X, you take your X and your Y, and they just exchange places. So what would N prime be? Negative 4, negative 3. Alright? So if we looked at it, 1, 2, 3, 4, 1, 2, 3. See, my line wasn't very good on that one. Like I said, this is kind of hard to draw on the smart board. Now, the N you can see is a half a unit diagonal, so you got half a unit on the other side. It might be easier to see on your paper, but the coordinates is negative 4, negative 3. Okay, so that becomes right here. And then we connect our points. And we reflect it over the line Y equals X. Okay? This was a half unit diagonal, so you go a half unit in the other direction. It's kind of hard to see. Huh? Right. Well, this right here is negative 3, negative 4. This is negative 4, negative 3. This line of reflection goes right through that square. That line of reflection goes right through that square. All right. All right. Let's look at the next one. Y equals negative X. Okay. Now that's like this one, but what's different? It's a negative one. So what's that line going to look like? Okay, look, this one's got a positive slope. Okay, let's think about it. Remember, Y equals mx plus b. What's the slope? Negative 1. And what's the y-intercept? 0. So it's just like this one, except it's got a negative slope instead of a positive slope. Okay? So, it goes through the origin. It goes through the origin, and it goes through this line right here. Okay? So, that one's got a slope of a negative 1, and it goes through the origin. Alright? So, same thing, since the line is diagonal, I have to hit the line at a diagonal. So I go across the square. So if I started with K, there is 1 unit, so I go 1 unit on the other side. That's a K prime. That's 1, 2, 3, 4, negative 2. Okay? L is 1 unit on the right, so I'm going to go 1 unit to the left, L prime. That is 1, 2, negative 3, positive 1. M is 1 unit below, so I go diagonal 1 unit. And that is negative 2, 4. What's happening here? They're switching places and they're changing signs. Okay? So if they switch places and signs, what's going to happen to N prime? It's going to become a positive 4, 3. Okay, it's going to become a positive 4, 3. So here I go diagonal 1, 2, 3. Diagonal 1, 2, 3. Let's see. actually, diagonal 1, 2, 3 and a half, and then a half, 1, 2, 3. So, and that is at 1, 2, 3, 4, 1, 2, 3. That's right. So my rule there, if you reflect over y equals negative x, your x and your y change places and they change sign. Now, what's going to happen if you have a point that lies on the line? What's going to happen when you reflect over that point? When you reflect over the line, where does that point go? It stays on the line, doesn't it? Right? If you're reflecting over that line, it just stays there. Just think, if you were to fold your paper along that line, wouldn't that point still stay right there? Yes. So it doesn't go anywhere. Alright? Alright. So here's a summary of the rules. You're going to reflect over the x-axis. You change the opposite coordinates, so the y changes sign. If you reflect over the y-axis, then you change the x sign. If you reflect over the line y equals x, then the y and the x switch places. And if you reflect over the line y equals negative x, they switch places and they switch signs. Okay? Alright. So, those are your rules. You should know how to graph it and use the rules. Alright?